looked at this. Okay, so this is a question. I will go for a quick demonstration. Okay, so you can see this is actually from solid mechanics. Solid mechanics, and theta is the deflection, m is the bending moment, v is the shear force, w is the weight. Okay, these are already mentioned, and we all know that if you went through the solid mechanics, if you differentiate or the shear force, you will get weight. Load, okay, this is load. If you differentiate the bending moment, you will get shear force. If you differentiate the slope, you will get bending moment. If you differentiate the deflection, you will get the slope. On the other hand, we can also say that if you integrate the load, you will get shear force. If you integrate the shear force, you will get bending moment. Okay, something like so. All the things are interrelated to each other. So this is the case is given. The distribution load is like triangular distribution of load. It could be triangular, it could be rectangle. So sometimes you might get these kinds of problem. Okay? So here the load is not directly given, but is in the way is like this. Anyway, so these expressions are given, and the location. So this the position for x equals 0, 1, 2, 3. The bending moment. The value of m, these are given. So here the values are given in tabular form. Okay, I'm going to explain it quickly. So first thing you need to do, you just spend some time. Okay, how to establish this one. What they said, I just go to the problem directly. From the table 3, find an equation that describes the bending moment as a function of location. That is, you need to find out the m as a function of x. Okay, so it means you have the table. So this is a what kind of thing? Is a regression or interpolation, right? So is it just you need to do the regression analysis. So in this case, you have 1, 2, 3, 4 points, and you need to consider m as a function of x. So you have to establish the relationship. You know already how to do the regression analysis. Okay, so in this case, which formula they use. So normally in the class test, remember very important is that they will not say that which formula you need to use. Like before in question 1, you can use second formula, you can use bisection method, you can use Newton-Raphson method. It's up to you. You decide how to do that. So it's very important for you. You decide how to choose the which method you need to choose. The method, which one you need to use, there it will be not mentioned. That's completely depend on you. It's your understanding, and then you judge which one you need to use. So here you have one. You already know that if you want to do the interpolation or regression, it doesn't say it like that. You need one equation, right? So you need one equation. You have 4 points. So which one you want to use? You can use Lagrange polynomial. You can use Newton divided difference polynomial. It's up to you. Okay, so which method you will use? So which order? Sorry. So we have first order, second order, third order. So if you see here, so you have 4 points. So you need to use third order polynomial. Okay, and they use the Newton's divided difference method. So you can use Newton divided difference method, or you can also use Lagrange polynomial. So it's up to you. If you just make the table, if you can make the table quickly, right? So remember that the Newton divided difference method is very quick. Okay, if you make the table, the Newton divided difference table, and just put the values, you will get the equation directly. So it's up to you. If you want to use Lagrange polynomial, also no problem. You will get the same equation. Okay. So there are two methods. Okay, remember Lagrange polynomial or Newton divided difference method. So it's up to you which one you convenient. Which is convenient for you. You can choose whatever you like. You make the table, you substitute the values, and then you will get the result. So you need to use the third order polynomial. The order is not mentioned, so you have to decide this. Four points is given, you must consider third order. Okay, otherwise the accuracy will be not like that. So you have the mx like this. The question A done. What are the bending moment? What are the value of bending moments? What are the value of m at x is equal to 0.5 and 1.5 using the equation obtaining A? So in the equation, just put the value of 0.5 and 1.5. You will get the value. Straightforward. C. Calculate the shear force V. Okay, at x is equal to 1 using numerical method. Okay, so numerical method, differentiation or integration is not mentioned. Okay, so here is say the shear force. You calculate the shear force. Okay, I go to the equation for shear force here. So in order to get the shear force, you need to differentiate the m. So you need to consider numerical differentiation. So numerical differentiation, you have this first order differentiation. Okay, so you use central method, or which method you want to use, you can choose it. So they say to find out the differentiation at what? At x is equal to 1 point. So if you are considering x is equal to 1, So you need to know the value of m here, 0, and this one. You can use the central difference method. So very easy, right? Just dm by dx. You use the formula here. Where is this? Okay, you use the formula here, and then you will get the value. You can see central difference method. So this one is x plus h minus x minus h divided by 2h. So here the value, you just put the value of this m 1.5 minus zero point 0.5 divided by 0.5. 2 multiplied by 0.5. So your h is 0.5 because here in this case is 0, 1 and this one, but you better you use the formula. Okay, so in this case they use 0.5, 1.5. So there is the indication of that. So you already got the value for 0.5 and 1.5. You can use this value. Okay, this is one option, and you can also use the value from here is 1, 2 and 1. Then your h will be 1. You can also use that. So in that case your result will be, I'm not sure whether I have enough time or not. If I don't have enough time, I put the quiz afternoon or evening, okay? Because this is important for you to finish the things. So this minus this divided by should be 2. So it should be how much? The value is, I don't know, or they didn't mention about this. So is 194. In this case, how much? 2.5. It should be half. 194. 3, I'm just calculating the things. 390, 57.63. Anyway, so there is the indication like this one, 0.51 and this one. So you just do the things, central difference method. Okay, it's very easy. So next one is D. Calculate the slope theta at x is equal to 0.5 using numerical method. Again, numerical method, which method? Differentiation and integration is not mentioned. So theta is equal to 1.5. So theta, you just go to the theta expression. So theta is this one, you see that. So in order to get the theta, you need to integrate this one. Integrate. So here what you need to integrate? Theta should be 1 over EI, right? Sorry. Then you have integration of m. So 1 over EI, this value is constant, right? So you can consider this one as constant, and then you can just use this, integrate this one. So you use some first rule, second rule, which one you want. So if you want to find out the value for in this case, which one they say, the value of theta at 1.5, right? So in order to integrate the slope, you need to integrate from 0, 1, 1.5, I think. So here you just integrate 0, 0.5 and 1 and 1.5. So here they use 1, 2, 2, 1. So they use the 1, 3, you can use 1, 3, 3, 1, okay? And then use the h should be 0.5. He used two sensor rule, 1, 4, 1, 1, 4, 1. So 1, 2, I don't know why is this like this. Oh, he used this 1 over 2. Okay, anyway, he shuffled his in way. So you can just integrate up to x is equal to 0.5. There are a number of ways to solve, okay? You just integrate 0 to 1.5. So you have 0 value, 0.5 value, 1 value, and 1.5 value. So you can use Simpson's second rule, 1, 3, 3, 1. Okay, then 3 by 8, 8 should be 0.5. You decide, okay, there is no only single way. So to solve the problem, there will be multiple ways. So you can choose whatever you like. So this is a way, very simple, right? But you need to understand. And if the analytical bending moment for this linear increase load is accurately described by the third order polynomial, now you can see. So analytical bending moment, you need to find out the bending moment analytically using third order. So this should be third order, okay? So you have this m equation. Now you just make the this value. I mean the bend. You need to find the shear force. You have to differentiate it analytically. So you have the m. You differentiate with respect to x. This is the analytical solution for your shear force. So if the shear force, the v you already got, try to get the value of v x is equal to 1 and 1.5. So you just get the value here, and theta you need to integrate m, right? So you do integration and put the value of that. So you will get the value. So some part is analytical because you already have the expression here. Do the if you want to get the shear force, you need to differentiate this one. If you want to get the slope, again you differentiate this one. You will get the things. Okay, this is analytical way, and put the values, you will get the answer. So this is the way you might face some problem in question one that will include most probably this. I mean, you need to get some expression and then do some differentiation integration based on the relationship. And at last, you might need also some analytical way. You need to know how to differentiate the expressions. Okay, so this is the question one, and there's another question. The question two will be ODE. Okay, I just focus here. Which one? So question two will be okay, ODE BVP, boundary value problem. So boundary value problem, we have two methods, right? Shooting method and finite difference method. This one I will explain finite difference method today. Most probably the shooting method, you will not get the things to be calculated, but as I said, there's something you need to know how to get the expressions, how to get the algorithm. You need to know the algorithm. Sometimes they might ask you how, if you want to solve this problem using shooting method, how you are going to solve. Okay, what are the strategies you will adopt? So you have to know those things. Maybe it will not include any solution, but maybe the last part of some questions. Okay, but most probably you need to solve the problem using finite difference method. And also one more thing, that you will see the question 2 and question 3, we will have ODE, ordinary differential equation. But we have, in case of ODE IVP, we have Euler method and Runge-Kutta method. Okay, mainly we use Runge-Kutta fourth order. Remember, Runge-Kutta fourth order. You have to remember that one. Forget about the second order. Maybe I will give you different problems for quiz. That is different. For the class test, Runge-Kutta fourth order and Euler method. So you can adopt any of it. Okay, if it is not mentioned, remember. So if you want to use Runge-Kutta fourth method or Euler method, you can use if it is not mentioned. But you cannot use those two methods for BVP. So you must understand what is the difference between IVP and BVP. That will be not mentioned that you solve this problem using Euler method, Runge-Kutta method, or finite difference method. Okay, you have to understand this is the initial value problem. So I have two options, so I can choose any of it. This is the boundary value problem. I have one option, shooting method you cannot use because it's too lengthy. Okay, you need to use the finite difference method. So like that. So I go to the finite difference method first. I try to explain briefly again. So you can see that knowing the method is not the things that help you to score. You need to understand the things, and you need to go through different types of problems from the book, and you must have some clear idea. Even you go through hundred and thousands of examples. Okay, you might not get the things common because we actually make it by ourselves. This is the creation of ours. So we need to consider those things to judge your understanding. Okay, I'm sorry. So I will go to the IVP. Sorry, BVP. I just try to explain the boundary finite difference method. Just hold on. Okay, so last time what I said, if you remember, this one, right? So when you have the problem, you need to understand that is it an initial value problem or boundary value problem? This is very important. So that's how we can differentiate this one. So there are some examples also. This is a boundary value. So you will see that they use the same parameter, but they will use different position. That is the boundary value. So they might use some beam. Okay, hold on. I will attach my digital board. Going to open it again, I think. Okay, so here, as I mentioned before, oh, I was talking about something like that. For example, if it's given like the deflection of a beam, okay, maybe column or something, so it's deflected like something like this. Okay, so at this point, the deflection is zero. Okay, maybe delta is zero. At this point, maybe delta is some value is given. So at this point position x is equal to 0. This is the maybe the length of the stick or anything, so maybe x is equal to L. So not only the temperature, you might have this problem. So at initial condition your deflection is this much, at the extreme end the deflection is this much. It can be a cantilever, you know, the cantilever beam. So if you have this one, you apply the load, it will deflect like this. Okay, so I can give the boundary conditions. So sometimes the conditions are not given. So you have to understand at this point, of course, your deflection should be 0. Okay, so your delta is 0. At this point, x is equal to L, your deflection is maximum. So that value will be given, but we have also some formula. Maybe the deflection, this part may be given in terms of some expression. Okay. So main thing is sometimes is you have to understand it is a boundary value problem or is it an initial value problem. Then you can decide which method you want to use. Anyway, so this one, as I said before, shooting method, you might only get some a small part of it, but you have to know, okay, how to solve the problem. For an example, if you have this one, so how to make, these are the expression like, so remember that the first thing is you whenever whatever equation is given, if you have third order equation, you have to linearize it in terms of three first order equation. So you have to do that. Okay, if you have fourth order equation, you have to linearize it as a four first order equation. That is very very important. Okay, that is the first thing that you have to do in case of shooting method. So sometimes you may see that the equation is given, maybe you have to linearize the things. Okay, maybe some equation is given, they ask you to linearize it into some n number of normalized first order equation. Okay, so if you have third order, you need to normalize it as a second order, I mean the third order three first order equation. Okay, so this is the task that you have to do maybe. And other things, this method, okay, this is very very important, the RK method. So RK method we use for where, in case of IVP, but because in case of shooting method we convert the BVP to IVP, that's why we are using it. And one more thing is very very important for you. When you will solve the problem IVP using Runge-Gupta method, there you will get the second order, not first order equation, second order. It means you have to solve two simultaneous first order equation. If you don't understand what I am saying here, so that will be here. So this part I haven't explained in Webex, but already I have the video. So you must watch that. Okay, you cannot rely only on my lecture when I meet face to face. This is just a brief explanation. So here you can see RK method I already explained. RK4 you already solved. This is only one equation, and this is the first order equation. You can see this is the first order equation, but you have to know this one. N order equation, this one. Okay, for an example, so this equation is given. Okay, so for an example, in case of IVP, this one is given. So what you need to do, you have to linearize it into two first order equation. So I hope you know how to do that. Okay, so this is the same way that we did here. Well, hold on. So the way is the same. So for an example, in this case, if you say that dx by dt is z, okay, so if you just put dx by dt is z, okay, so I just write dx by dt is z. This is the first equation. So then you will have what? You will have a dz by dt, right, plus 3z plus x is equal to 5. So you have two order. So now you linearize it into two first order equation. Okay, so now you have to solve these two equations using RK method. So you have to adopt the way that I explain here. You can see I solved two first order equation using RK method, but in this case you just solve one time. Okay, it's depending on the steps. So if they said like step size is this much, you have to reach that one. So maybe you have to comply only one step. So then you will get the things like this. After 0 you will get 2 and then 4 and 6, depends. They will not ask that much, maybe only one step or two steps. Okay, so you have these values, something like that. So that is very important. Okay, so make sure you have watched my video. So again, something like that. So in order, you need to reduce into two order. There are other examples. So in this case, they consider x2, you can consider z. Okay, so if you confuse with x1, what is x1, what is x2, you confuse, then you just consider z, should be okay. This one also same. So you have to consider x dot should be z. So then it should be z dot. Okay, so minus this one. So you have two equation in that case. Again, same like this before. You have x dot, first order differential equation is z, and second equation will be sorry, this should be z dot, right, minus mu 1 minus x square multiplied by z is equal to, this is first order, this is first order. So you have two first order, then solve the problem. Initial condition will be given for those two. So this one is a third order. So you have to consider three first order equation. So you can please go through this one, how they consider. Okay, so this one, if you consider this is z, now you need to consider two variables. So they consider y, and then so I go to the first order equation here is right. So this is the first order 1, and this is 2, and the last one is here, this one. Okay. So you will have the three equations. So the first one is here, right? So we have rewrite this one, and this is the first order, and this is the second equation. So if you put these two, you will get the third equation from the here. Okay, anyway, you need to solve this. So maybe up to second order, third order, you will not get this that much complicated. So you just consider up to a second order equation, and then you need to solve the problems. Okay, so these are the three equations in short. So we consider from here dx1 by dt should be x2, and we simplify it like this. So we have three equations you have to solve using the RK method. Anyway, so I come here. So when you solve, again I'm saying the same thing. Try to use this strategy. So k11, k12, and then use the function and just put the value 1, 2, 3. Then you use the expression and get the values. Is better, okay? And remember that you have to, no formula will be given. You have to remember the formulas. Okay, so last time I also said that that should be 2, right? If you remember, that should be 2. Okay, anyway, so the part of the shooting method is Runge-Kutta method, and this Runge-Kutta method you have to use for IVP for second order, I think. Okay, so I go to the finite difference method. That is very easy. I already described some part of it last time. So in case of IVP, sorry, finite difference method, you have to solve this equation again here using Gauss elimination, Gauss-Jordan elimination. So you are not allowed to use any internet or any Excel. Okay, so it takes time. It takes time, but to get the equation is very easy. Just put the values. So again, the things which method you will choose, it will be not mentioned. You need to decide. You need to put the central difference. Okay, be careful. So this will be not mentioned. So you already need to know how to solve the problems. So for an example here, so this is actually fourth order. Okay. So in this case, of course, the initial conditions should be given. If it is not given, you have to understand the conditions. Okay. So for an example, this is a y is the deflection in this case. So it's y4 is a y4 dot p divided by ei. P means the load. P is the load. Okay. So they ask you to find the deflection of the uniform fixed beam. So the both ends are fixed. You have to find out the deflection using finite difference method. So using what, it will be not mentioned in your class test. So h is given, interval h interval is 9, so total is 636. So you have to consider 4, right? So 9, then 18, 27, and 36, right? So can you remember? Can you remember that, or can you calculate what are the load for this point, and this point? Because you need load, right? So at this point, the load is how much? 0. So the load is how much? Is 0, right? So, and in this, at this point, your load will be how much? Is linearly decrease 100 to 0. So this is 50. At this point is 100. At this point, it should be 50 because this is middle of it, right? And then this is the 0. Okay, so how to solve this problem? So you need to know the conditions. Okay, so here you have a fourth order equation. So you need to have 4 conditions. If you have 2 equation, a second order equation, you only need 2 conditions. If you have fourth order equation, you need 4 conditions. So 4 conditions are here at this point is fixed end. Okay, if it's fixed end, the deflection is 0 and the slope is 0. Okay, so remember that. What is slope? If this end is fixed and you have the rod, you want to apply some load here, this cantilever, it will bend like this. But at this point, there is no slope. Slope means theta. Theta means dy by dx. It means change of y direction with respect to x. So at this point, there is no slope. There is no curvature. Slope means curvature. So this is fixed. So there is no curvature. So that is the condition. This one. And here, same condition, but x is equal to x. So you have 4 conditions. You have fourth order differential equation. That's okay. So now what you need to do, you just need to apply the fourth order finite difference method. So apply this one, the fourth order method. How you get the fourth order? You will not get the fourth order, as I say in the class, but yeah, you have this fourth order. Is the fourth order, right? So they use this one. So if they use the fourth order central difference method here, you can later on you can match, okay, which method they use. So recall the fourth order central finite difference. So we always use central here. So just put the values. You have this expression. Okay, so now you have this. You already know that at I is equal to 0 and I is equal to 4. You already know the values. So you just need to know I is equal to 1, 2, and 3. So they just put the value I is equal to 1, 2, 3. They have the expressions like this. Generalized expression, okay? And for I1, there is a P. You can see here, there is a P. Yeah, sorry. So this is Pi. So P depends on the positions, right? It's not constant. P depends on the position. So that's why I ask you to find out the value of P at different location. So so here, after you put the values, okay, what you will get like this equation. So here you can see that you have, this is a different problem, okay, it's different strategies. So you can see there is a y minus 1, but you don't have y minus 1 here. Okay, you have y0 should be okay. 0, 1, 2, 3, 4 also okay. In case of this one, you have y5. You also don't have y5 here. So these are known as fictitious point, like that the point that we don't have, but we are getting the points inside the equation. Because if you put I is equal to 1 here, you can see 1 minus 2 is minus 1. And this one, 2 plus 3, if you put I is equal to 3, 3 plus 2 is 5. So you have these 2 extra points. That is fictitious points, sorry. So you will get the fictitious points when you have third order, fourth order. Second order, you will not get this one, so don't be worried. Okay. So if somehow you got these kinds of point, there are ways to solve. So in order to get this one, so there are fictitious points here. So how to get this value? You need to create the relationship. So how to create the relationship? So at this point, you know that, right? The slope is zero. At this point, the slope is zero. It means y prime zero should be zero. At this point, y prime at this point is in this case is L is zero, right? Slope is zero. So now you apply the central difference method, first order differentiation. So that will be this minus this divided by 2h should be zero, right? So at this point, I apply the boundary condition. So in this case, so you can create the relationship between this and this. So if this is zero, so there is, you can see this y1 is actually equal to y minus 1. So the y minus 1 is actually y1. So you can replace this one with this. Easy. Similar way here also is fixed end. So this minus this divided by 2h should be 0. So that means this one and this one, the value deflection is actually same. So that's how we can solve the problem of fictitious points. So now you just substitute, just change the y minus 1 with y1 and y5 with y4. So then you have these two values and put the values, you will get the answers. Okay. So you have to arrange y1, y2, y3. You have only three equations, three unknown, three equations. You can solve the problem easily. So here, this one, P1, P2, and P3, you need to know this load. So here is the load, how you can get. As I say, for P1, it should be 50, P2 should be 100, and P3 should be 50. It depends on the condition. It's not like that. So sometimes the distribution is different. You have to find out the point, the load acting on that. If it is straight, then, sorry, if your value is something a straight one, is like straight, then it's all same. Okay, sometimes it's like this, but I don't think you will have these kinds of complicated things. Not complicated, it will ask you to think. Okay, maybe it's like this one is straight, and then after that it's slanted. This one also can be done. Okay, so anyway, so no need to be worried. Okay, so you will not get any complicated things. I mean, the things can happen like that. So you have to know the points and then solve the problem. So after you get this one, you just solve the knowledge that you already have: Gauss elimination, Gauss Jordan elimination. So it means for the class test 2, you also need to reshuffle your knowledge about the Gauss elimination, Gauss Jordan eliminations. Okay, because you have to use those things here. Otherwise, if you can solve using calculator, should be okay, but you are not allowed to. I don't know, maybe the examiner put some marks how to solve this matrix, some part, and you are not showing the details. I'm not the question maker this time, so it depends on the examiner. If you really don't have time, solve it and then use the calculator. Better you give the answer, okay, instead of keeping it blank. I think you can solve it from your calculator. I don't know, or you just adopt some strategies. I'm not sure. I cannot say anything. So you just try to write down the answer because it takes time. Okay, I think they will allow some. They will allocate some marks for that. Maybe 4 marks or 5 marks. I don't know. So that's the way we can solve. Okay, so find the solution of boundary value. So this is another one using finite difference method. You can try. This is straightforward. You will not get the things straightforward. So it's a second order and the first order, and then you have this one. So just put the expression, second order central difference. Okay, then we have the first order and then this one. So at least try to remember the formulas because the formulas will be not given, and then use the finite difference method to solve the problems. Okay, so you need to practice. Okay, you need to practice, and as I said, you can solve the problems using RK2 method. Try to solve the problem. I don't know whether they have one problem in the book. I will show you 1 minute. Numerical OD. This is which one? No. Okay, so I go here first. Mm, ODPVP. Okay, so this is VVP. Some part already I explained. This one already explained. This is BVP. Shooting method, no need to waste your time here. So yeah, find the solution of the linear equation using finite difference method. So solve this problem. It's straightforward. Okay, so the second order, first order. So equation is like this, but you might get maybe logarithm, exponential things, complicated. Maybe you can have third order, second order, first order. So you have to know the formula. Remember, without formula, you cannot use anything. So they just substitute the values, okay, and just you need to understand the thing, okay. So the boundary is here and here, so you just name it x0, x1, x2, x3, x4, and x5. So in this case, your x0 and x5 already known. You need to find out y1, y2, y3, y4, but you already know x1, x2, x3, x4 because you know the age. If the age is not given, you can decide by yourself. Okay, something will be open in your class test. Okay, everything will be not point to point. So some maybe the age is not given. You can decide how many you want. Okay, so after you substitute the value, you have some general equations. Okay, instead of y1, y2, and yi plus 1, yi minus 1, something like that. And then you have this general formula. Then you just put the values. Okay, you try to discover the things. So we have 4 points. So you need to understand that you have 1, 2, 3, 4. Of course, you will get 4 equations. Okay, so you have to substitute the value of I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. So you have 4 equations, but I don't think you will get 4 by 4 matrix in the class test. It takes time. But just to make sure that you can solve these kinds of problems. So the final solution, you will get this one. It's straightforward, okay? Um, So the thing is, you just make the general equation first, and then substitute the value I is equal to 1, 2, 3, 4, and then get the equations for that corresponding point, and then solve the equation and make the matrix. Okay, before the solve, you make the matrix, and then apply the strategies to solve it. In this case, this one is cylinder. Find the radial distribution of the temperature with inner radius 5 and outer radius 10. Okay, so inner radius R1 and R2 is given when the inner and outer surface is maintained by 120 and 60. So in this case, the inner temperature is 120 degree and outer is 60 degree. It means if you go from inside to outside, the temperature is reducing, right? So the temperature difference in this case is actually negative because it's reduction. Okay, so you need to consider the flow direction. Okay, so if it's going this way, so it depends on whether your temperature is increasing or decreasing. So if this way, if decreasing, it should be negative. If increasing, it should be positive. Okay, so this is actually shooting method. They use Rongikutta. Okay, so maybe no need to go through this one maybe, but remember that yeah, we have two equations. So how to solve the two ODE using RK? That is a good example. So you better follow the slide that I mentioned. Okay, try to give some time, and you will definitely understand what I was saying there. So if you understand, then you can solve any problem. I mean, this one. Just spend some time on this part. Yeah. So this will not for BVP, but it will help you for IVP. Um, I'm not sure the question. Okay, so if the question is said second order, they will ask you to reduce the second order equation to first order, and you have to solve the simultaneous first order equation. In order to solve the simultaneous first order equation, this is the way to solve. Please give some time to solve it. Okay, how to solve? And so, if it is first order, then no need to worry about this K11, K12. Okay, if you have different strategies, if you can understand in different way from others, also should be okay. As far as you answer correctly, there is no problem. Okay, so I go to the difference method here. So this is the load is in this case is straight. Okay, determine the deflection. Deflection should be y. There is no mu. Okay, so they want to find out the deflection of the beam at x is equal to 250, 500, and 750. Okay, using ODE. So if you have this kind of beam, normally you need to find out the problem that boundaries. Okay, so normally if you have this kind of structural item, they will not give you the boundary condition, because you have to understand that if you have the support at this point, your deflection is zero. At this point, your deflection is zero. There is no way. Okay, so to get the deflection, so this one is not directly mentioned, but you have to understand. You cannot say, oh, I don't know where is the boundary condition is not given, is not allowed, like that. Every information should be given. Sometimes you have to understand. So this is clearly a boundary value problem. Okay, so then you have to find out, okay, x is equal to this one, your length is 1000, you have to find out 250, 500, and 750. You have to divide it into 4 equal parts, right? And then use the central difference formula. This one will be not mentioned in your class test, so which formula you have to use, you have to decide by yourself. Calculate the relative true error for each deflection. If any analytical solution is like this, if y is like this, you have to find out the true value and compare with the result. So you can see the boundary condition, x is 0 and x is equal to L. So your y is 0 at x is equal to 0, and y is 0 at x is equal to L is given. The step size 250, no problem, and just put the values there and get the value. So the value for P is actually same. P should be 100. If you have the triangle, as I showed last time, then you will have different P for different points. This one is constant, so in all cases P1, P2, and P3, your P will be 100. Okay, so you have some general equations, and then you can use this one 250, 500, 750, something like that, or you can just use better, you use x0, x1, x2, and just consider y1, y2, y3. So it's very easy instead of considering these points. Okay, so it will save your time, and also it will help you to avoid the confusion. So you have these 3 by matrix to solve this problem. You will get these things, and the value of y already given. So the true values are already given and approximate values. So you can get the relative error. I think you can calculate. How you can calculate the true value? The y is already there. You put the value of L already 1000. EI already given. X value is 250. You will get the y for the corresponding x. Sometimes it's given like this. Sometimes the expression is given. You have to differentiate or integrate, as I showed in the PDF file for the question number 3 last time. So how about this one? Okay, so also we have some radial distribution. That is not a problem. The radial distribution these are Poisson ratios. The value should be given. Okay, and is this like this? And again, the boundaries. Is it a boundary value problem? Find the radial stress distribution. So you have to find out the distribution. So this is, I think they use a shooting method here. I don't know which method they use. Just I scroll down. Oh no, find a difference. Okay. So you have to find out the radial distribution. It means you have to find out d sigma by dr. This is your case. Okay, you have to find it out. And so you have to do that. It means how the sigma change with respect to r. It means the value of sigma for different r. Okay, and step size they say 2, and inner is how much? 1, and outer is 7. So 2, 1, then 3, then 5, then 7. This is straightforward, very easy. So you have this one, second order central difference. You have to know this one, first order central difference. So you just put the values, simplify it. I is equal to 1, 2, 3. In this case, it's radially distributed. You have the matrix solving. It's straightforward. Same way here. Anyone is saying something? 1 minute again. Okay, so this is another problem. This d square x by dt square. This is matrix and these coefficients are already given. So this is the acceleration. Okay, solve the equation for displacement using numerical method over the time. What is the velocity of t? And give two methods that can be used, improve the accuracy. In this case, again, second order, first order. So you just make the put the values there. You can have the solution. So after you get x1 and x2, okay. So you need to know the v, right? They ask you to calculate the velocity. Solve the equation means you have to find the value of x for different t, and then they say the velocity at t is equal to 2.4. So you know that 2.4 you have to use the central difference method. So this should be x is equal to 1, okay? x3 minus x1. So you already know the value of x3. So you have to use the numerical differentiation in this case, right? So this is not ODE, this is straightforward. So you already know the value of x for different points. So if you want to get the 2.4, so you have to x3 minus x1. Because your x1 is, the distribution is like this, 0, then spacing is 1.2, and then 2.4. Okay, so if you have this one, this is the thing, x0, x1, x2, and x3. So your x2 is here. So in order to find out this one, you need x3 minus x1 divided by 2h. These values already you know. x3 is a boundary condition. x1 you just calculated. So you just use this one, you will get the velocity. So how you can improve? Improvement can be if you use a smaller h, you will get better result. If you use higher order accuracy equation, higher order derivative, you can also improve your results. Sometimes they may ask you some theoretical part to answer in this way. Okay, so there are some questions here. I think most of it I already explained. Okay, so please try to solve. If you have any problem, let me know because your class test is very closer. And one more thing is, oh, hold on. ODE. So you already solved one RK method with one order, but I will ask you to solve it for second order. Wait, one moment. ODE. Okay, so this is IVP, Euler method, Rongikuta method. This one I already explained. This is maybe Euler method, right? So there is a problem with velocity calculation, velocity and position. I think which one? Just hold on. I think this one. So yeah. Okay. So please try to solve this problem. This is a task. Okay. After the quiz, please try to solve this problem. Or just wait 1 minute. Fourth order. Okay, I'm sorry, not that one. 8.7. This is the problem. So motion of a damped mass system in the this figure is described by this one. This is a very famous example for spring mass system. Okay, and you have to solve this one. X displacement time C is there. Initial distance. Solve the equation by numerical method over time. Okay. So you no need to plot. Okay. So please try to solve this problem for the betterment of your class test. Okay. Try to exercise this one. Try to solve this one using RK method. So it's a second order. You will get two first order equation and solve this problem. Okay. In this case, the value of k already given. The spring constant k is given. The initial velocity is 0, and the initial displacement x is equal to 1. So when the time 0, your displacement is 1, your velocity is actually 0. These are the two initial condition, right? That is IVP. So you solve this equation using a numerical method. That means you have to use Runge-Kutta fourth order over the time 0 to 15 seconds. So you just consider maybe you consider t is equal to 5 seconds. Okay. So just consider 5, 0 to start initial condition 0, then 5, 10, and 15. Let me know the result. So please, I will check the results for you. That will give you the confidence to solve the problems. If you have second order, so this is a second order IVP. Okay, so this equation, this one is solved using the in MATLAB. Okay, so you have to solve it by yourself manually. This is the first order. First order is easy. Please try to solve it by yourself and post it in the WhatsApp group. So I will check for it. Okay. If I do some, please do it by today. Then otherwise you will forget. You have other things to do also, right? So please try to solve this one and let me know. So I will cross check. And if you have any time, which method? Always RK4 method. Euler method is not used. Use RK4 method. Okay. So if you most of the time we use, as I said, RK Runge-Kutta fourth order. Please try to solve it. And when you will solve, even though it's saying second order, what do you mean? No, second order, first order. You can solve this problem using Euler method. So second order, if it is, even it is second order, you first thing is you have to make it two first order equation. Second order, if it is fourth order, you have to make it four first order equation. You cannot solve second order. Okay. So you have two first order equation, then you can solve it either Euler method or RK method. But we most of the time we use RK4 method. So that's why I say to use RK4 method to practice that. Or if you are interested, you can also use Euler method to do that. Okay, so in the class test, okay, in the class test, if it is not mentioned, that you have to solve using RK4 method, you might choose Euler method because it's very, very simple and quick. If it is said use RK4 method, then you have to use RK4 method. Okay. So I maybe some student may trick and they use Euler method. I'm not sure. Okay. So most of the time we prefer to use RK4 method. I'm not sure which method they ask you in the class test, but if they don't say anything, so you can choose actually Euler method. So we cannot defend that. So if you want to do that, please, if you have enough time, try to solve this one either using, I mean, try both. Okay, using Euler method and RK4 method. So you will see that the differences, the results. Okay, please give some time for that. That will help you to solve the problem in the class test. Anyway, that's all from me, and that's also for all for ODE BVP. Okay, you need to solve the problems. I'm not giving you the problem to solve, but I ask you to solve it and study by yourself and let me know, okay, if there is anything wrong, or if there anything I can do for you. So next thing is I will upload the project, okay, individual project 2 by today, and this project is based on PDE. So I will open my lecture for PDE maybe by today or tomorrow. So you have to watch the PDE lecture before I deliver my lecture, because otherwise you will not have enough time to solve the problems. Okay. So we have only 2 weeks left, and you have to submit the project by 15th week, I think. So I will try to disclose the question by today, and also open my lecture, recorded lecture. Okay, even though we meet on Webex, so you have to watch it to accelerate your project work. Yeah, yeah, individual. There is no group project for numerical method. All are individual project. I already discussed with others. So all individual project. And okay, that's all. So you will have the quiz maybe after, from 12:15. You can check the e-learning from 12:15. This problem is very easy. Okay, just score well in the quiz, but don't expect these easy questions in the class test. Okay, that's all from me. Thank you very much. If you have anything to ask, you can ask on the WhatsApp. I will try to answer it. Okay, so just wait for the quiz 12:15. Okay, thank you very much. Goodbye.